Hello everybody, welcome to Free Coder. Here you can learn all about programming.
Welcome to the Explainer. Today, we're talking about the one simple change that can make your code so much better. And no, it's not about learning some hot new framework. It's about changing how you think about complexity itself.
So let's kick things off with a little confession. This is from a developer who spent 15 years, a decade and a half in the trenches. And after all that time, they realized the single best piece of advice is just keep it simple, always, and run like crazy from over-engineering.
Okay, and this slide, this just perfectly sums up the problem, right? We have all seen code like that mess on the left. What do those numbers even mean? It's a total mystery. You'd have to go digging around the codebase just to figure it out. But the version on the right, that makes sense instantly. And the huge difference between them? It all boils down to one simple idea.
For a long time, the developer we're talking about just called this problem unnecessary complexity. But you know what? There's a much better, much more precise name for it. And that name is cognitive load. That is the real enemy we're all fighting every single day when we write code.
Okay, so what is cognitive load? The best way to think about it is like your brain's RAM. Seriously, you only have a limited amount of working memory. Once you hit that limit, every new thing you try to cram in there just pushes something else out. And you know what happens then, right? That's when mistakes happen, that's when bugs are born.
Now here's where it gets really interesting. It turns out cognitive load comes in two flavors. First, there's the intrinsic load. Think of this as the inherent difficulty of the problem you're trying to solve. You can't really change that. But then there's the artificial load. And that's all the complexity we create, the tangled mess we make with our own code. And that is 100% in our control. And that's it. That artificial load is where we should be putting all of our focus. It's exactly why principles like composition over inheritance are so powerful. Instead of building these complicated family trees of code that you have to track in your head, you're just snapping together simple, independent little blocks. It's way less mental bookkeeping, which means more brain power for actually solving the real problem. So here's the crucial takeaway. If our number one goal is to crush that artificial cognitive load, then we have to start looking at our so-called best practices a little differently. Maybe with a bit of healthy skepticism. Because, sometimes the road to complex code is paved with good intentions. I mean, it sounds like total heresy, right? Breaking the don't repeat yourself principle. Dry is like lesson number 1 in programming school. But here's the thing. Sometimes breaking a rule like that is absolutely the right move if it makes your code simpler and easier to understand. And don't just take my word for it. Rob Pike, one of the creators of Go, famously said, "A little copying is better than a little dependency." Think about that. A few extra lines of code that you can see right there, all in one place, can be so much easier to read than some tangled, abstract dependency that makes you jump all over the codebase just to figure out what's going on. Okay, let's look at a perfect example. Check out this method call. True, false, what do those even mean? What are they for? Without jumping to the actual method definition, you have literally no idea. This, right here, is pure, unnecessary, artificial cognitive load. But now, look at this. In a language like Kotlin, which has named parameters, the difference is night and day. The cognitive load just vanishes. Poof. You can see exactly what's happening at a single glance, and you don't have to leave the file you're in. The code documents itself.
And this points to a bigger, deeper truth, doesn't it? We're told that patterns like the builder object in Java are a best practice. But are they really? Or are they just a complicated workaround for a problem the language itself created? You're adding a bunch of extra complexity just to make the code readable. Complexity that wouldn't even be needed if the language had better features.
Okay, enough theory. Let's get practical. Let's talk about your simplicity playbook. I've got 4 things you can start doing, like right now, to cut down on that cognitive load and make your code way easier for everyone, including you, to understand.
All right, so here's the toolkit. Use descriptive naming, flatten your logic, get rid of those magic numbers and codes, and, this one's key, resist early abstraction.
First up, let's talk about the pyramid of doom. We've all written it. This deep nesting of if statements is an absolute nightmare for cognitive load. It forces whoever's reading it to keep track of every single condition in their head just to understand what that little bit of code at the very center is supposed to do.
So how do you fix it? You flatten it out with guardrails, or guard clauses, early returns, whatever you want to call them. You check for all the bad stuff up front and just exit immediately. By doing that, you clear those conditions out of your mental RAM right away, and that frees up all that precious brain space for the code that actually does the work.
And this same idea applies to your variable names and those magic numbers you see everywhere. Your goal, your mission, should be to make your code read like plain English. Seriously. No one should have to guess what a Boolean called allowed actually checks for. And nobody should have to memorize that HTTP status 418 means I'm a teapot. Just be descriptive.
So all these little tips and tricks, they all point to a bigger philosophy, a powerful, and maybe even a little counterintuitive idea about what we should really be aiming for when we sit down to write code.
That's it. The ultimate goal, the highest praise your code can ever get, is for it to be boring. Yep, utterly and completely boring. Not clever, not elegant, not intricate, just boring.
And look, boring is not an insult, not at all. In this context, boring means the code is so clear, so obvious, so predictable that the next developer, who by the way might just be you in 6 months, can open it up, understand the logic without having to ask anyone for help, and feel confident enough to make a change on their very first day without being terrified of breaking everything.
And what does this mean in practice? It means resisting that little voice in your head that tells you to add extra patterns, more layers, new abstractions just because you think you might need them later. Come on, you know the one. If you don't have that problem today, right now, then you're just adding artificial complexity for a benefit that might never ever happen.
So it really all boils down to this one thing. The next time you're writing some code, designing a system, whatever it is, just stop for a second and ask yourself this one simple question. Is what I'm building clear, or is it just clever? Honestly, the answer to that question might be the real secret to becoming a much, much better developer.